Hi everyone, this is Mrs. Snowbeck. Today we are going to do a one-day unit called the logic unit. And we're going to start with some vocabulary at the top of the page. Inductive reasoning. It's coming to a conclusion based on specific examples. For instance, you might notice a pattern, so you come to a certain conclusion. The next term is conjecture, and a conjecture is a conclusion based on the pattern or inductive reasoning. It's basically an educated guess. So a conjecture is an educated guess. And then a counterexample is an example that proves a conjecture is false. And I think the best way to learn this stuff is just to try some. So number one, make a conjecture about the product of two even numbers. So think about this for a minute. Product means multiply. So if you multiply two even numbers, can you make a conjecture? Can you make an educated guess about what would happen? If you're thinking the product of two numbers is going to be another even number, I think you're right. I think when you multiply two evens, you're going to get an even. Let's try a few. Like 6 times 8, 48. 10 times 20, 200. Yeah, those are both even answers. Think of another number like 4 times 16. I think that's 64. And so again, if I multiply two even numbers, I got an even answer. And so my conjecture would be the answer will be even. That's my conjecture. It's my educated guess. Number two, find a counterexample to show that the following conjectures are false. So this time somebody made a conjecture like part A. Angle A and angle B are complementary angles. And if they're complementary angles, then they share a common side. Okay, well, that's what somebody thinks. Can we prove that that is wrong, that that's false? Just because two angles are complementary, do they have to have a common side? Well, think about complementary. What does that mean again? That means they add up to 90. So is there some pair of complementary angles that add up to 90 that don't have a common side? And I think the best way to prove this one wrong is to draw a picture. So for instance, what if I draw a picture of a 30-degree angle and a 60-degree angle that are separated? They don't share a common side. This would be a counterexample. Just because they're complementary does not mean they share a common side. So counterexamples, they always fit the first part. This first part is true. A and B are complementary, but then to prove it false, we find a way that this doesn't happen. The second part does not happen. Let's try another one. So part B, if a ray intersects a segment at its midpoint, then the ray has to be perpendicular to the segment. Okay, let's draw a segment. Here's our segment. Now, put a spot at the midpoint. Okay, put a dot there, a point at the midpoint. So here we have a segment, and there's a point at the midpoint. And now what we want is we want a ray to intersect this segment at the midpoint. We want this first part to actually happen. We want a ray to intersect this at its midpoint. But we do not want the ray to be perpendicular. We want to prove that this statement is false by drawing a counterexample. What if I just draw a ray like this? That is not perpendicular to the segment, but it does intersect the segment at its midpoint. So this drawing that I just created would be a counterexample. It proved that this statement is false. Number three, determine whether each conjecture is true or false and give a counterexample for any false conjecture. So part A, if the area of a rectangle is 20, then the length is 10 and the width is 2. To be true, this has to be always true. To be false, you have to find out, is there a rectangle that has an area of 20 but does not have a length of 10 and a width of 2? Well, what about a rectangle that is 4 by 5? Would that have an area of 20? Yeah, if you multiply 4 times 5, you get 20. So this is going to be a false conjecture. And my example, my counter example, is what if we have a length of 4 meters and a width of 5 meters. I still get an area of 20, but it's not a 10 by 2. Please pause the video and try parts B, C, and D on your own. When you're done, unpause the video. I'm going to do part B with you now. If angle 2 and angle 3 are supplementary angles, then they form a linear pair. Well, I think this is going to be false, because just because two angles are supplementary does not mean they have to be a linear pair. For instance, maybe I'll have one angle like this and one angle like this. They're 90 degrees each, so they are definitely supplementary, because supplementary means they add up to 180. But they aren't a linear pair, because remember, linear pairs are a line that's been divided into a pair like this. And mine that I drew with the two 90-degree angles is definitely not a linear pair. So I think false, and I have a counter example. How about the next one? If you're 62 years old, then you are retired. Can you think of someone who is 62 years old and not retired? Again, I think this is probably false. I'm trying to think of somebody who's kind of older and still working, and one person that came to mind is President Biden. President Biden's definitely older than 62 years old, but he is not retired, so he would be a counterexample. If angles 2 and 3 are complementary angles, then they have a sum of 90. Are there any complementary angles that don't add up to 90? I don't think so. This is actually a true statement. There are no counterexamples to disprove it. The second part of our vocabulary, a conditional statement. It's an if-then statement. If P, then Q. The first part of that is called the hypothesis. The hypothesis is the phrase in a conditional statement that directly follows the word if. The conclusion is the phrase that directly follows the word then. So go to number 4. If two lines form right angles, then the lines are perpendicular. We have an if-then statement. This is known as a conditional. A conditional statement is an if-then statement. So they want us to underline the hypothesis once. Well, the hypothesis follows the word if. So in this case, two lines form right angles is the hypothesis. They want us to underline the conclusion twice. Well, the conclusion follows the word then. So the lines are perpendicular is the conclusion. The hypothesis follows the word if. The conclusion follows the word then. So part 5, can you write this statement as a conditional? So what they want us to do is they want us to take the statement and change it into an if-then sentence. So 16-year-olds are eligible to drive. 16-year-olds are eligible to drive. Think about, can we change that to an if-then statement? I think we can. What if we say, if a person is 16 years old, comma, then they are eligible to drive. We have changed that sentence into a conditional, an if-then sentence. As you can see here, we have some conditionals. Will you take a minute and try to determine if each statement is true or false? And if you think they're false, give a counter example. Go ahead and pause the video. Part A, if you live in Minnesota, then you live in Farmington. This is definitely false. So an example could be my mom. She lives in Elk River, Minnesota. So is the first part still true? Does she live in Minnesota? Yes. But does she live in Farmington? No. How about part B? This one's a tricky one. If x squared equals 16, then x equals 4. True or false? I probably fooled you on this one. It is false. And the reason is x could be negative 4. If you square negative 4, you also get positive 16. So negative 4 is a counterexample. I'm going to leave the last two up to you to finish, and then go to the next slide. And our final section of vocabulary, we're going to talk about the converse, the inverse, and the contrapositive of a conditional statement. Now remember, a conditional is an if-then statement. For example, number 7, if you live in Minnesota, then you live in Farmington. The converse is when you take those two parts and you flip them around. You flip around the hypothesis and the conclusion. So we would say, instead of if you live in Minnesota, we would say if you live in Farmington, then you live in Minnesota. So instead of if you live in Minnesota, then you live in Farmington, we took the if and the then and we flopped them around. If you live in Farmington, then you live in Minnesota. Do you think this converse is true or false? Can you think of someone who lives in Farmington who does not live in Minnesota? The answer is actually false. So there is a Farmington, Michigan. I think there's a Farmington, I don't know, there's at least like 5 of them. There's at least 5 other Farmingtons, probably more. So I'm going to say false, because what if someone lives in Farmington, Michigan? Next, let's talk about the inverse. So if you look up above at the vocab, it says the inverse is a statement formed by negating both the hypothesis and conclusion of a conditional. Okay, so if you negate something, you make it negative. So it says if you live in Minnesota, then you live in Farmington. The inverse is if you don't live in Minnesota, then you don't live in Farmington. You make both parts, the hypothesis and the conclusion, negative. Let's write that out. If you don't live in Minnesota, then you don't live in Farmington. So we negated both the hypothesis and the conclusion. Let's think about, is this inverse true or false? Can you think of someone who does not live in Minnesota, or can you think of a place that's not in Minnesota but is in Farmington? Yes, I can. So I'm going to say false. And again, I can use Farmington, Michigan. Or maybe, I think there's a Connecticut, or I don't know. There's other states that have Farmingtons. The third situation is the contrapositive. Let's read what it says up above. A contrapositive is a statement formed by negating both the hypothesis and conclusion of a converse. Whoa. Okay, so go up to part A. Remember how we did the converse? The converse was if you live in Farmington, then you live in Minnesota. Well, to get the contrapositive, we have to negate that, both parts. So we're going to use our converse and make the beginning and end both negative. So it's going to say, instead of if you live in Farmington, it's going to say if you don't live in Farmington, then you don't live in Minnesota. That would be called the contrapositive. You take the converse and you negate the hypothesis and the conclusion of it. What do you think? Is this contrapositive? Is it true or false? If you don't live in Farmington, then you don't live in Minnesota. I think that's false, because I know some of you probably live in Lakeville. So an example would be, you don't live in Farmington, you live in Lakeville, but that is in Minnesota, Lakeville, Minnesota. So that's the end of the video. The rest of this packet is yours to finish, so go ahead and give it a try and let me know if you have any questions. Have a good day.